This is 6.1 in your textbook. It's on page 322. So we're looking at interpreting data. And this ties in nicely with the Khan Academy. If you did your Khan homework last night, we were talking about lines of best fit. Okay, if you saw that, we're going to cover that a little bit more in a little bit more detail tomorrow. But this is an introduction to that idea. Okay, so the first step is taking information that's in a table format and converting it to a graph. Okay, and everybody should be familiar with doing that now. We're just plotting those points. Okay, when we do take the table, we want to know what is the independent variable and what's the dependent variable. That dictates where we're going to put these values, whether it's going to be on the x value or on the y-axis. Okay, so typically when we're given a table, how we usually, what you see in the textbook is that they'll give you usually the x variable is first. Okay, so if they give you a table lined up like columns, usually it's labeled like this, x and then y. Okay, that's because the idea is that y depends on the value of x. So y the dependent variable, x the independent variable. Likewise, when they line it up for rows, they typically line it up like this, x and y there. Okay, again because y is dependent on x. In some cases, you can actually argue one is an independent. You could actually argue that either variable could be the independent value or independent variable. Okay, it's actually kind of up to debate, and this is one of them. Okay, so we're talking about a number of sit-ups that a person does in relation to the time spent working out. All right, so you can argue, you can say, well, she chooses how long she's going to go to the gym for, and therefore that her number of sit-ups depends on how much time she spent at the gym. Okay, if that was the case, then if she's choosing her time would be her dependent variable, right? And then it would be the opposite way. In this case, the book is suggesting that the time spent, her number of sit-ups is actually measured by the number of time she spends at the gym. Okay? So this is time is your independent variable, and your number of sit-ups is your dependent variable. So, but you could argue this either way, no?
If a question like this was on a test and it was one of those where you could do it either way, could we do it either way?
Yeah, as long as it's justified. Okay, so if it's a communication problem, you would have to just explain why you chose it that way, just like I did right now. Okay? But the other way around, if you choose, let's say your number of sit-ups is your independent variable, so you're going to choose how many sit-ups you're going to do, then you could argue that time is your measurable. So you're going to say, how long does it take me to do 100 sit-ups? In that case, this would be reversed, right? Because you're measuring time. So measuring time is your dependent variable, and it's dependent on those 100 sit-ups that you're choosing to do. Okay, you see how I can argue it both ways? Yeah. I'm choosing the time, how long I'm going to spend in the gym, and I'm measuring my amount of sit-ups. I'm choosing how many sit-ups I'm going to do, and I'm measuring the amount of time it's taking. You see? So this is one of those tricky scenarios where it could be either or for your independent or dependent variable. Okay, you just need to justify it. Remember, your dependent is the one that your independent is the one that you're choosing, and your dependent is the one that you're measuring. Any questions about that? All right, so once we've done that, we've chosen in this case that time is our independent variable, and our sit-ups is our measured variable. Now we take this information and we plot it. Can anybody tell me why the book has told us? A little bit confusing here because my dashes look like points, but I'm going to draw it a little better. So the yellow points are the actual plotted points from this graph, and then I have a dashed line. Anybody know why I'm using a dashed line to represent this relationship? Yeah, David.
No, it's because it's not continuous, it's that secret because you can't do like half a sit-up.
Right, and that's the point in the book. You might argue, well, you can do half a sit-up. Okay, but that would only be for, maybe the very last one. You're not going to do, 3/4 and then a half sit-up, so really it's a discrete value. you're counting your push-up, your number of sit-ups that you do. Yeah?
Isn't the other way around that it's a straight line if it's discrete?
No, it's straight if it's continuous.
Okay.
Okay? It's discrete if it's broken.
Okay.
Alright? Discrete means like separate. Alright? Okay, so it says the question reads, describe the relationship between the completed sit-ups and time. So who's going to try and do that right now? Somebody describe this. What's going on? Carlson.
It's increasing.
Okay, good. So the number of sit-ups completed increases as we spend more time in the gym, yes. But there's something else going on here. You're right, but there's something more than that. Yeah, Daniel.
As the time gets higher, he does less sit-ups.
Yeah, so like later into her workout, so after she spent about 3 minutes doing sit-ups, the number of sit-ups is slowing down. She says she's doing less sit-ups for the amount of time that she's spending there. So why might that be? Josh?
Fatigue.
Yeah, fatigue. She's getting tired, right? So the idea is we're going to describe the relationship between the completed sit-ups and time. So sit-ups increase with time, but slow down because of fatigue. Alright, so that's the idea when you're answering these questions, is you got to try and visualize what's actually happening. In this case, we're measuring the amount of time that she's working out, and we're measuring the sit-ups. Okay, as this curve is slowing down, we see that she's doing less sit-ups for the same amount of time, so she's actually getting tired. That's it. Example number 2. Determine if there's a relationship between throwing speed and age. So I have my graph here. Again, we have a table of values, and typically, in this case, we got to again decide what's going to be independent and what's dependent. This one's a little more straightforward, okay? Because you definitely are measuring your throwing speed, right? That's the dependent. And you definitely can't control how old you are, right? So that's your independent, all right? So you're choosing the age and you're measuring this, yeah.
Doesn't the throwing speed depend on the pitch you're throwing?
Throwing speed depends on the pitcher, yeah.
But let's, like, if you're throwing a knuckleball, the pitch speed is going to be a lot slower than if you're throwing a fastball.
Oh, the type of pitch you're throwing?
Yeah.
Yeah, so we're assuming here that they're all throwing fastballs because we're measuring the speed. All right? Yeah, it's a good question. It's not stated explicitly, but the assumption is they're trying to throw as fast as they can. Okay? The question reads, is there a relationship between the throwing speed and age, so maybe throwing speed of fastball? Yes, Matthew.
How come age is in decimals?
Sorry?
How come the age is in decimals?
Because we wanted to plot it on a graph. So in order to do that, we took like the months and converted it to a decimal version of a year. Okay, so if you were 14 and 6 months, it would be 14.5. All right, do you understand that? Any other questions
Without
about that?
decimals, you can't graph it?
Sorry?
So without decimals, you can't graph it?
How would you graph 14 years in 3 months? You have to have 2 units.
Or
in
you want the months exactly too?
Yeah. You have to have your x-axis with 2 variables, and that wouldn't work. So we're converting the months to years. All right? Any other questions with that? And so then again, if we're looking at this data, even though we can't draw a line per se because it doesn't appear, if you look at it, there doesn't appear to be any sort of line that I can draw. What kind of line would I draw? If there was a relationship, would it be a dashed line or a solid line? Yeah.
Dash line,
Dashed line, why?
because it's not linear, it's like all over the place, so.
Think about it again. Roland.
It's not continuous.
It's not continuous. Think about the x-axis. Okay, we're measuring it in decimals, right? So Josh,
I think it'd be a solid line because it's depending on the age and everything, and like you said, you have your decimal ages and decimal throwing speeds, so therefore it is a solid line.
Yeah, it definitely would be a solid line, okay? If I were to say draw a relationship through here, if there was some sort of pattern, I would draw a solid line, okay? Because you can be, 14 and a half years old. You can be 14 and 3/4 years old. So it would be a continuous pattern, okay? However, looking at the graph, we can see that there is no pattern, okay? There's no set line I can draw through here because, all the points are just scattered all over the place. So in this case, it says determine if there's a relationship between throwing speed and age. I would say no. No relationship. Okay? And the reason why is because there's no discrete pattern or no continuous pattern. So to review that concept, I'm just going to have a little graph here. And we're going to try a couple of different colors. So,
Sir, here's a copy of that.
no, you don't have to. All right, so we have this scatter plot here. Let's assume that there was a table of values, and these yellow points here that I've put on the board, that's the result of me plotting out a table of values. Okay, so we're going to learn a little bit more detail about this tomorrow when we talk about line of best fit. But what I want you guys to notice is that just for the purpose of this section, is there a pattern or is there a relationship here between y and x? So if you notice here that as we start with really low values of x, we have low values of y. Okay? Even though we do have this point out here, and we have a point way up here, we still do have this kind of general pattern that's going in that direction. Okay, so in this case, I would say yes, there is a relationship. Okay? As the x variable increases, the y variable increases. So again, I'm talking about the x variable first because it's independent. The y is depending on x. And it appears to me that as x increases, so does y. Okay, so I would say for this particular pattern, yes, there is a relationship. How about this pattern? Michael, is there a relationship for the purple pattern?
Yes,
Yeah, why? What is it?
because it increases, like, the x values kind of stay the same, but the y values increase.
Okay, so we have this kind of vertical line pattern happening. Right? Is that a relationship? Is it? Whenever we encounter a graph and we get a vertical line, usually we say something, yeah.
No, because like it's the same x value but different y value.
Exactly. So in this case, we keep getting the continuing x value, and what we're finding is that our y value is all over the place. But for generally the same x value of, let's say, 10, we're getting all different values. Cool. So can I predict any sort of pattern from happening? No, not at all. If my value of x is going to be 10 again, I'm not getting any sort of pattern. Yeah.
Wouldn't it be undefined? Because any number over 0 is like there's no slope.
Yeah, there's no slope, and there's no pattern. There's no pattern. What we need to see for a pattern to happen is we need to see some sort of relationship where we can predict what the value of y is going to be based on the value of x. Okay? For the yellow graph, for instance, if I choose an x value way over here, I pretty much know my y value is going to be much greater than here, right? It's going to be somewhere up here based on what we've seen so far, right? For my purple pattern, if I choose an x value here, I'm not going to see any. I don't know where it's going to be. It could be anywhere. All right, so finally, last one. Orange, Michael Sacchetti, can we notice a relationship? Is there a relation?
Yeah.
Is there a relation? Yes, there is. And what is it? We're going to find out more about it tomorrow. But that's, yeah, it's a negative correlation. Very good. Okay, that's the end. Check out the summary page, please. Don't forget this. Just